Good morning students, welcome to Narayana Live Session Classes. Today we are going to discuss the assignment of 10th class under the topic current electricity. Let us see the first question in that. If a copper wire is stretched to increase its length by 0.1%, the percentage of increase in its resistance will be, right? So here the length, percentage of length that is delta L by L into 100 is 0.1%, increasing percentage of length, okay, right? So as the wire is stretched, right? So volume will be same volume it will have, right? There won't be any change in volume, okay? So from the formula, R is equals to rho L by A, right? To get the volume here, because volume is constant and the same material, resistance will also be resistivity will also be constant, okay? So here if I multiply and divide with length, then R is equals to rho L by A into L by L. So the formula will be R is equals to rho L square by A into L is volume, right? Okay. So from which R is proportional to L square. R is proportional to L square, right? So here we got the proportionality as R is proportional to length square when the volume remains same, right? So by this, if I get into the percentages, right? So here now percentage change in resistance is equals to, as power is raised to 2 into percentage change in length, right? So percentage change in length, it's already given 0.1, so 2 into 0.1%, which is equals to 0.2%. So percentage change in resistance is 0.2%, right? Let us get into the second question. A wire of resistance 18 ohms is drawn, that means it is also stretched until its radius has become half of the original radius, then resistance of the wire, okay? So here R1, radius, right? So R1 is equals to R and R2 is equals to original radius by half of the original radius, right? And the resistance, actual resistance is 18 ohms. We need to find the resistance when it is stretched to half of the radius, right? So from the formula R is equals to rho L by A, right? So here we need to get the volume equal, right? So as it is stretched, volume will not change. So as wire is stretched or drawn, right, volume is same, right? Volume will not change. So what happens here is, if I multiply and divide with area, rho L by A into A by A, then the resistance will be R is equals to rho L into A by A square. This L into length into area is nothing but volume. So here R is equals to rho into volume by A square. But as we are speaking about radius, then area will be equal to pi r square, right? Then our radial resistance will be equal to rho into volume by pi r square whole square, right? So resistance will be equal to rho into volume by pi square r power 4. So here we get the relation between resistance and radius as r is inversely proportional to fourth power of radius, right? So r is inversely proportional to radius to the power of 4, right? So let us solve it out. So r1 by r2 is equals to r2 to the power of 4 by r1 to the power of 4, because it is inversely proportional, right? But we need r2. So here r2 by r1 is small r1 to the power of 4 by small r2 to the power of 4. So finally r2 will be equal to r1 by r2 whole power 4 into r1, right? So r1 and r2 we know. r1 is r, r2 is r by 2 to the power of 4 into 18, right? So here it is 2r by r whole power 4 into 18. So 2 power 4 into 18, right? Now 2 power 4 is nothing but 16. 16 into 18 is 288 ohms. So the final resistance is 288 ohms. Okay. Right. Now let us get into the third question. If an iron wire is drawn to decrease by its radius 0.5%, okay. So decrease in radius, that is change in radius percentage change in radius is given as 0.5%, okay. The percentage increase in resistance or percentage change in resistance, right? Now here we have seen already in the last previous example, right? Here the resistance was inversely proportional to fourth power of radius. So r is inversely proportional to fourth power of radius, right? So change in resistance percentage change in resistance as it is raised to fourth power 4 into percentage change in radius, okay. So percentage change in radius is given as 0.5. So 4 into 0.5, which is 2%. Okay. So the change in resistance of the wire will be 2%. Okay. Now let us get into the fourth question. A conductor liquid is filled in a vessel of area of cross section, right? A up to a height h, then resistance of the liquid. Okay. So here as r is equals to rho L by A, here length can be treated as height because it is filled to a height h, right? So r is equals to rho h by A. The resistance of the liquid will be rho h by A, right? So this is the assignment for this day, students. We will meet in the next assignment. Thank you everyone.